Hi, I'm Tom. I'm going to talk a little bit, as Matthew said, about some stuff we've been doing with SnapCI and Heroku on the client project we're working on at the moment. This is me. I'm on social media. I made this. If you're a JVM developer, you might recognise it. I work with Energize Work. Doing sort of consulting and software delivery type stuff using agile and lean and DevOps and continuous delivery type techniques. So yeah, just to give a little bit of starting context, we're working on a client project at the moment. It's for Pottermore, which is the sort of official Harry Potter website. It's the place you go to buy Harry Potter ebooks and audiobooks and all that sort of thing. You can go there and read original writing by J.K. Rowling. It's kind of evolving into a sort of digital experience where people who are fans of the series can kind of go and dig a bit deeper and sort of continue enjoying the story after they've finished reading the books and so on. So at the moment it's primarily kind of a content managed website. It's quite rich. There's quite a lot of complexity in terms of the way it renders and content publishing rules. It's responsive and so on like that. There's some kind of personalization type stuff on the way that hasn't been released yet. I can't talk too much about that, but so there are two sort of key components to it. Technology-wise, it kind of largely consists of this stuff. It's JVM backend, so we've got a Ratpack application and a DropWizard application. There's quite a lot of sort of front-end toolchain type stuff. So we're using ES6, which is kind of being transpiled down to ES5 in the browser. We're using SCSS to generate CSS. And we've got this kind of big mashup of build tools, so Gradle for sort of wrapping everything up, and then you've got sort of NPM and Gulp doing the front-end bits. Obviously, as I said, we use SnapCI for kind of build and workflow automation, and we deploy into Heroku, and we have Fastly CDN, and we use GitHub for source control. All fairly straightforward so far. I think kind of, as I say, the main point I want to make here really is that the build process is quite involved and quite complex. So there are these two sort of distinct sets of components that have to be built, and there are quite a lot of moving parts. There's two dependency managers in there, making builds robust and not take lots and lots of time is something that we've kind of had to work quite hard at. So SnapCI and Heroku. Is there anyone who doesn't know what SnapCI is? Okay. It's essentially a SaaS CD pipeline. So you plug it into your GitHub repositories, and it picks them up, and it picks up your security details and your projects and all that kind of thing. And you can very quickly and easily kind of configure builds. So it roughly does what Jenkins would have done in the past, but it's hosted for you, and the integration with GitHub makes it a lot easier to get started with. And obviously all the sort of worries about managing all the underlying infrastructure go away. You just kind of pay them to do that for you. So this is what it looks like. It's simple sort of straight line pipelines. Obviously some of these are sort of build steps, and some of them are testing steps, and some are deployment steps. Hopefully fairly straightforward. Has anyone not heard of Heroku before? No. Okay. I'll kind of skip over Heroku then, because we all seem to know it. It's Heroku is like developer crack, I think. It's and this is the main reason I think is add-ons. They're this nice workaround for your procurement department. Once you've got your billing details in there, like that's it. You could, the sky's the limit. You can do whatever you want with it. So we like Heroku a lot. And Snap and Heroku between them allow you to get things up and running very quickly. They provide a very low friction sort of entry point. Into whatever it is that you're building. So you can make a quick start, and for us, really all this was we added a step like this into our Gradle file. We added a file like this into the root of the project. This is a Heroku proc file that just says this is how you start the application, and then finally we said to Snap do basic Heroku deployment, and that was pretty much it. That's a walking skeleton of a load balanced multi-node app with a database behind it, more or less in well under an hour, a few minutes even. So we did this initially when we were setting Pottermore up, and life was good for a while. but we quickly sort of ran into a sort of fairly fundamental problem with it. One of the ways in which Heroku works. So Heroku, its heritage, I think, is as a Rails host, and obviously, Ruby is all source code. There isn't a notion of a binary. So what you used to do, what their model is essentially you do a Git push into their Git repository, and they just kind of take that and do something with it. This isn't really so great when you're doing JVM applications because there's a build step in the way, and it's even worse when you've got something like npm in the mix. Every npm install I think is a completely unique event. And when you're doing it over and over again, sort of in deployment stages, then you have all sort of manner of random failures and latency and all sorts of stuff like that. So this became problematic fairly quickly. We were finding that deploys would fail in different ways at different stages down the pipeline because of things that were going on entirely outside. It also kind of meant that we were building the thing in Snap and we were testing it in Snap, and then we were rebuilding it inside Heroku. And there's always that sense that if you build something in a different environment to the one that you tested it in, then you're opening yourself up to problems, resulting from the difference of those environments. So we wanted to kind of get away from that as well. Another problem with their way of doing things by default, where you push your source code in there, is that they have a fairly tight size limit on the slug, as they call it, which is kind of their equivalent of a Docker image. So you have a maximum of 300 megs, and if you go over that, then it just won't let you deploy anything. And if you've got all your source code in there, in addition to the thing that you've built, then there's a pretty good, you end up going over that limit fairly quickly. So that's kind of a problem as well. And then the other problem we had, which was kind of infuriating, is that because it's Git push based, you can't repeat a deployment of the same commit, because Git won't let you do it. It'll just say everything's up to date. There's no work to do. So obviously we wanted to get past this and get to something better, and the solution we came up with kind of came in three parts. So the first one was we thought we need a binary repository, and we need to build the binary at the beginning of our pipeline and then ship it out there so that it can be reused in subsequent deployment and testing steps. So we realised that GitHub Releases is actually a great fit for this. GitHub Releases is essentially this. So whenever you have a GitHub repository, you tag things in it, you kind of create these placeholders for releases, and you can chuck in a bit of markdown text to describe what's going on in the release, and you can attach files to it as well. So this was perfect for us. Obviously there's an API that lets you push stuff in there, so you can do it programmatically from within your build. So that was the first part. The second part is that Heroku has this concept of build packs. So initially we were using one of their out-of-the-box build packs, which knows about Gradle builds. And you put that sort of single line into your Gradle file where you say stage, and it will call that, and that does whatever's necessary. But you can give it your own build pack, essentially just by pointing it at a Git URL that's sort of somewhere public. And a build pack is really just a collection of scripts. And all it does is say, assemble the file system in this thing that turns into the slug. And then once you finish doing that, it takes that and kind of packages it up and ships it out to all the servers that are going to run your app. So you can do pretty much anything you can do with a shell script inside of a build pack. You don't have to use specific build tools at all. So what we did is we actually built a really stripped down build pack, and all it does is do a wget for a jar file. So it assumes it's getting a fully built jar file that's runnable with an embedded web server, which works really well for a whole load of frameworks. So Play Framework, and Ratpack, and Drop Wizard on the JVM are all kind of function this way by default. So it's nicely compatible with sort of anything that follows that model. And the other key thing about this is your source code doesn't need to go anywhere near it. All you need to do is push this little kind of metadata file that says, use this jar file, and here's how you authenticate against the, wherever it's going and getting the jar file from. So at the moment, it will pull it from a sort of unauthenticated public source. It will pull it from Snap's own binary repository, and it will pull it from GitHub Releases, which is what we ended up kind of using in the main. So yeah, as I said, you have to put these things out somewhere public. So we thought we may as well open source it. So this is actually on the Energize Work GitHub organization, and anyone can use it. As an aside, there's always going to be a WireMock angle in my talks. Because YMOC builds to a runnable jar, and you can you can just kind of start it up standalone. So if you do this, then you'll end up with a GitHub app with YMOC running it in about sort of 2 minutes flat, I think. Which we've actually done in a few cases. It's quite good if you want to sort of unit test your CDN. If you want to kind of isolate your CDN and test your configuration without your app being in the way, then this is actually quite a good way of doing it. So yeah, finally, so the third piece of the puzzle was to write our own Gradle plugin, which really just kind of ties this stuff together. So it generates this little metadata file that gets pushed into Heroku, and does the other little sort of bits and pieces to it to orchestrate the workflow, and obviously actually pushes the binary into GitHub releases in the first place. We are planning on open sourcing that, but we haven't done it yet. It's still sat in a private repository at the moment. One little technical detail, I don't know how interesting this is. So to avoid the problem where you're sort of pushing all your source code needlessly into Heroku, the way it works is just to kind of create an orphan branch, which has got nothing on it apart from these metadata files, and pushing that instead. So after we did all this is kind of what our process looked like. Hopefully it doesn't need too much explanation. So the jar file is coming out of SnapCI and being pushed into GitHub releases, and then being pulled out by Heroku at the point that you need it after you've triggered a deployment. So the next problem we encountered is that there were still certain kind of failure modes that we had during deployment. There were still certain things that could go wrong and that would end up leaving an environment in a bad state, and us not necessarily knowing about it without having to poke it and prod it a little bit. Specifically, if we'd forgotten to add some environment variables that some new feature required, if we'd added, the database add-on in one environment and forgotten to add it in the one we promoted it into, that sort of stuff, that would obviously cause problems. Sometimes there was some non-add-on but third-party service that we were using that we'd not set up, API keys and all that kind of stuff. And the other one that really bit us actually was untested code paths. So you have a switching configuration, and it's been switched one way in a series of environments, and then you deploy it into the live environment, and it switched the other way. That wasn't fun when that happened. So we wanted to set about kind of making sure that it was both less likely for this sort of stuff to happen, but also that we'd know about it a lot more quickly if it did. So there was two parts to this solution. The first one was the compile step, so this kind of pre-deployment phase that the Heroku build pack gives you, actually gives you an environment which is identical to the one that your app will finally run in. So you have all the same environment variables, you have the same sort of underlying OS and binaries available and all that kind of stuff. So what that means is you can actually start the application, with all of its environment present, hit the health check page, and which will then go out, fan out and check all the dependencies, and then close it down again. And if that hasn't succeeded after 20 seconds or whatever the timeout was that we set, then you halt the deployment, and that means that whatever you've done there gets thrown away. It doesn't end up being promoted into your environment, so you get to keep your previous deployment without having kind of trashed it by putting something bad through. So we did that, and then sort of more traditionally, we had some kind of post-deployment tests, which were from the snap build pointing back at the environment that we just deployed into, and that would be, first of all, checking that the app was returning the commit ID that we expected, and then secondly, that sort of things like, certain responses were coming back correctly, or CDN rules were being honoured, that kind of thing. And that would fail the pipeline step, so we'd all get an email, and the Slack channel would scream, and alarms would go off everywhere if that failed. So that kind of added these few extra steps to the overall process looking like this. Sorry, the other thing I didn't mention actually is that we ended up kind of expanding the pre-deployment step out to make it not just a verification step, but after that initial verification to also use it to do things like migrate the database, push configuration to the CDN, migrate the content model and all that kind of stuff. And the nice thing about doing it there was it meant that you can actually just push stuff straight into a Heroku environment in one step, and know that the entire workflow for getting the thing deployed, including all the sort of peripheral, configuration of third-party systems that has to happens in there as well. So it sort of means that you can create these little ad hoc environments that aren't on the Snap pipeline and deploy to them in the same way, and you get this very uniform process across all of it, which is also easier than managing this sort of two ways of deploying things, I suppose. So the final thing I thought I'd mention, there are a couple of things that Heroku have got in their labs process at the moment that might sort of obviate the need to do all the sort of stuff I've talked about just now. So one of them is that they have a beta feature, which is you can just push a Docker image straight up. And I think this would be awesome, because obviously then you're not just building the thing that's sitting on top of the OS layer that's going to get deployed. You're actually building an entire image with low-level packages and everything kind of rolled up into it. So you get about the sort of highest level of consistency between deployments, I guess you could probably get by doing that. And the other feature they have is this thing called pipelines, where you still have to kind of let them build one of their slugs in the first instance, but then they store that for you, I guess, much like a Docker image, and they allow you to promote it through kind of higher environments. The slightly strange thing about this is they've got this completely sort of constrained template. They have a fixed workflow rather. So they have, you go from kind of dev to QA to live, and that's it. There's no option of going off into other environments or doing things in between. So again, this is in the labs process, so maybe they're going to expand it and generalize it once they've kind of got the basic workflow right. But I think that would be probably a more convenient alternative to what we're doing in a lot of ways. And that's about it. Thank you very much.